Hello everyone, and welcome to your interview on the Slope-Intercept Form. So there are lots of different ways that we can organize our thoughts when it comes to line equations. But this right here is my favorite, possibly everyone's favorite. I don't know for sure, but for sure my favorite because it is just so darn useful. It's easy to remember. Everybody who's mathematical knows it, and you can tell so much about the slope of a line or the look of a line or the action of a line just by looking at this one equation. So let's talk about the slope-intercept form. Now, this is the way it's written, y equals mx plus b, and y is, your y coordinate, and x is your x coordinate. So those two are just your xy values. The m always stands for your slope, and the b always stands for your y-intercept. That's what those numbers always mean when you're in the slope-intercept form. So let's take a look at an actual equation. If I gave you this equation, y equals 2x plus 3, then here would be your y value, here would be your x value, your 2, this is your m, which equals your slope, and this 3 is your b, which equals your y-intercept. Okay, so I just want to make sure that you kind of understand that, what these numbers mean. Now, let's take a closer look at this equation right here, y equals 2x plus 3. And let's pretend that I told you that I wanted you to graph this equation, y equals 2x plus 3. So I'm just going to 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. I'm just going to hand draw a little chart here. So you already know, since I'm hand drawing this chart, that nothing is going to be perfect, right? If I wanted perfect, I would need a computer and or at least a minimum of a straight line and a graph paper, but I don't have those, and so I'm just going to do an ish right here. And then if we're going to graph this line, I'm just going to rewrite the equation, y equals 2x plus 3, and I'm going to say, hey, let's make an xy chart, right? If we can plot 2 points, then we can draw ourselves a line. And just to make this more challenging, I'm not going to allow us to pick 0 as one of the points. I know that is totally mean of me, isn't it? Because we've already learned that 0 is super helpful. Instead, I'm going to say, okay, let's make x equals 1, and we'll make x equals -2. What does that give us? Well, we can still do it in our head, I think. If x is 1, then that would be 2 times 1, which is 2, plus 3, so y would be 5. And if x is -2, this would be -4 plus 3, so that would be -1. So I'm going to plot those points. 1, 5, 1, 1, 2, 3, 4, 5. This is 1, 5. And -2, -1. -2, -1. And I am going to draw myself a very ishy line right here, kind of like this. Okay. All right, so that's what my line is going to sort of look like. All right, so now let's play with this line a little bit and see what we can figure out. So the first thing that I want to do is I want to figure out the slope of this line right here. So the slope of this line, if I were to measure from this point, -2, -1, oops, it's not the color I want. Here we go. And I were to draw a right triangle here, then this point right here would be what? Well, it would be -2, 5, right? Because it's over -2 on the x-axis and it's up 5 on the y-axis. And so what is the distance of this line? Well, the y value changes from -1 to 5, which is a change of 6, right? Because to go from -1 up to 5, you have to take 6 steps. And our x value changes from a -2 to a 1, which is a change of 3. So if m is your slope, which is the change in rise over the change in run, or if you wanted to, you could think of it the change in y over the change in x, right? That would also be legit. The change in y is 6. The change in x is 3. 6 divided by 3 is 2. Notice that that is the number that is there in our formula, right? So we just confirmed that the slope of this line is indeed 2. But I don't have to go through all of this work if my equation is in slope-intercept form to begin with. I can just look and see that it's going to be 2 without doing any graphing or calculation. That's a beautiful thing. Here's another thing that we can do if our equation starts out in slope-intercept form. I can look at this number right here, 3. Do you remember what that is? That's our b, remember, which is our y-intercept. So let's go over here and look at this line. We are looking at about where this line crosses the y-axis. Now in my chart, it 1, 2, 3, it looks more like 3.5 to me, or maybe even 3 3/4. But the real answer here is 3. And if I were to exactly draw this out, you know, with graph paper and straight lines and all that sort of stuff, you would see that this line would cross exactly at 3. Now this is very helpful sometimes because sometimes math tests, they give you questions like this. Can you see this? Okay. It says, hey, we have this equation, y equals 2x plus 3. Which of the following could be a graph of the equation? And just by knowing this, the point is 3, you can eliminate this, which crosses at the negative number, and you can eliminate this, which crosses at a negative number. So I'm just going to get a different color. So I'm saying, okay, we eliminate this and we eliminate that, because those clearly do not have a y-intercept of positive 3. These two maybe do, right? Those are 3-ish. But now I notice that my slope is positive, which means that this one has to be my answer. This is a negative slope, so that one's wrong. So do you see how helpful it can be? I didn't have to do any calculations. I didn't even have to have numbers on my graph, and I was able to figure all that out just by looking at the slope-intercept form of the equation. Okay, so that's awesome. So what? Well, here's where it gets a little tricky. What happens is that math books, math teachers, life, they don't always give you the equation in slope-intercept form. This is the equation of a line. You can see that you have your x term and you have your y term, but it is not in slope-intercept form. How do we get it in slope-intercept form? Well, slope-intercept form is, remember, y equals mx plus b, which means that y has to be by itself and positive. And if you can do that, then you're in good shape. Y has to be by itself and positive. So let's switch this equation around so that y can be by itself and positive. So the first thing that I'm going to need to do is I'm going to need to move this x term over to the other side of the equation. So I could do that the long way by subtracting 3x from each side, or I could do it the faster way, which is just by saying, hey, I want to take this term and I want to flip it to the other side. I am totally allowed to do that as long as I change the sign of that term. So it now becomes negative 3x plus 9, because I flipped it to the other side and I flipped it to a negative. Okay? Now, all I have to do is divide by 6. Now, some students write it like this, which is totally fine. That is fine for you to do that. Although, I think that that makes life a little less certain than if I were to write it like this. Divide it by 6, and then I divide each term by 6, because that's what I want to do, is I want to divide that whole side by 6. And this makes it easier for me to work with, I think. This is not wrong, I just prefer this. So that is now going to equal negative 3 over 6, which is negative 1/2 x plus, and 9 over 6, that's going to reduce to 1.5. You will notice that the slope term, your m right here, is usually in fractional form. And that's because then we can calculate the rise and calculate the run, right? This over here, I don't care if you put it in fraction form or if you put it in decimal form or if you put it in Roman numerals. Well, okay, I do care about that. No Roman numerals. This does not matter as much. In fact, it might be kind of nice for you to have it as 1.5 as opposed to 3 over 2, because when you graph it, it's easier to figure out where 1.5 is, right? Okay, so that's it. So you take this equation and you mess around with it until you get y by itself and positive, and then it's in slope-intercept form. Let's do another one. Let's do this one. Let's do negative 4y plus 12 equals 8 over x. All right, so what are we going to do first? Well, we want to get y by itself and positive. So the first thing that we're going to do is we're going to take this 12 and we're going to flip it over here. So that's going to be negative 4y, that stays the same, equals 8x, so I haven't changed anything yet, but now since I'm moving this 12 over here, I have to make it a negative 12. You could do it like that if you want. If you want to do plus negative, that makes you happier, go right ahead. Okay, then we have to get rid of this negative 4. And so we have to divide each term by negative 4. So we get y equals, this will be negative 2x. We have a negative divided by a negative, so we're going to get a positive answer, 3. Negative 2x plus 3. Let's do one more. This will be our last one. We have negative y plus 7 equals 4x. So the first thing that we'll do is we'll move our 7. So we have negative y equals 4x minus 7, because again, it's going to go from a positive 7 to a negative 7, because you're flipping the side. Then we have to get rid of this negative. So now you could go through and you could say, okay, I'm going to divide everything by negative 1, which is totally fine because that is exactly what you were doing. I, however, don't usually write all that out. What I do is I say, oh, I want to change this sign. Well, if I want to change this sign, I have to change the sign for everything. So this becomes y equals negative 4x plus 7. I flip this sign, and this sign, and that works just fine. So that's my slope-intercept form. Super, super, super helpful to know how to put equations into slope-intercept form. So helpful that I made you watch an entire 14 and a half minute video on it. I hope you were paying attention.